Good evening to all. Yes. Hope you all are fine. Yes. Okay. Today we are going to discuss about the fifth module. It deals with the sheet metals and its characteristics and what are the various processes carried out. So my question here is, you already experienced this sheet metal in your first year, right? What difference you noticed when you deal with the sheet metal as well as the material which is used in your fitting lab? What difference you have noticed there? Please tell. Yes. Yeah, you might have seen certain variations in the dimensions. Yes, that is the main dimension is the thickness. You can see that. The thickness for the sheet metal should be less than 6 millimeter. That is the case. So those materials which is having the thickness less than 6 millimeter is considered to be as the sheet metal. Okay. So we can undergo various processes, that is various forming operations can be conducted as well as the cutting operation can be conducted. Okay, by using the sheet metal, cutting, bending, then shearing, and then drawing operation can be performed by giving the tensile force on the sheet metal, and then spinning operation that is used for making cups by placing it on the lathe. That is a shape like this can be made by using the spinning operation. Okay. To undergo these much processes, the sheet metal should possess certain properties, certain characteristics. Okay. So today we are going to discuss about what are the various characteristics for a sheet metal. Okay. What are the various characteristics of a sheet metal? So let's see one by one. The first one is tensile elongation. Elongation, or simply we call that as elongation. So what about your opinion about this elongation? Elongation means the change in length. Okay. What opinion is there? Yeah, Vaishnav says that it should be high. Okay. What about others' opinion? Okay, I also agree with that. Let's see. Look, a material having so much length, and we can see that this portion is elongated more, this portion is elongated more, and this portion is elongated less. Like that, it is attained. So is it good? No. It is not fair, right? Yes. So elongation must be uniform throughout this material. That is one important characteristic of a sheet metal. Yes, the elongation can be improved by means of strain hardening that you already learned in the previous semester. That is when a material is subjected to tensile load, beyond the elastic limit. Yes, what will happen? It undergoes the plastic deformation and it is released. And if again that same material is subjected to tensile load, we can see that the elasticity improves, right? Okay, that we learned in the previous semester in the metallurgy material science. Okay, so the same way we can improve that elongation by means of proper heat treatment also. Okay. Is it clear to all? By means of annealing process, we can also attain that elongation in a better way. The second one is yield point. So, what is an yield point? What is an yield point? You might have heard this yield point, isn't it? What is a yield point? Yeah, maximum yield. That means what? The change in length will be maximum. Isn't it? The change in length will be maximum. Why? Because the internal resistive force per unit area. What is that? That is the stress developed. The stress is what? Internal resistive force per unit area will be less. Yeah, at that point. Internal resistive force per unit area will be less at that point. That's why it elongates more. That is, yielding will be more over there. Got it? It elongates more. So the sheet metal should have surely the yield point. So due to that yielding, there exists certain bands are there. That is similar to the stretch marks when you go to the gym. The white mark or black marks will be there. So like that, bands will be here also here there. That is what we call as Dewey's band. That is what we call as the stretch marks. Okay. That is because of what? Because of this yielding of that sheet metal. Okay. So that is in the case of the yield point. Is it clear to all? Okay. Next is the third one. The third one is dealing with the anisotropy. What is anisotropy? Have you heard this anisotropy? What is anisotropy? Yeah, it is the same, isn't it? If I take a brass material, it is alloying components are what? The copper and the zinc. Okay. So when I make that alloy, will that uniformly distributed? No, isn't it? When I make that alloy brass, will it uniformly distributed inside this one at the time of a solid solution? Is it? No, it will not, right? So what we have to do? We have to give certain heat treatments, isn't it? To make it uniform, isn't it? So we have to make that anisotropic material isotropic material, isn't it? By means of what? By means of certain heat treatment process that you already learned in the previous semester, isn't it? So by means of annealing, we can change the properties. So that is how the anisotropic material has to be made, converted into isotropic material. So anisotropy will give a bad effect on the sheet metal. So that is another characteristics. Okay. So it should be isotropic in nature. And then fourth one is grain size of the material, grain size of the sheet. Okay. So if I am taking the coarse grained sheet, what shall be the condition? When I perform the bending operation, what shall be there? What is the problem there? Problem noticed. If the grain size is a coarse one. Any idea? Yeah, Abhijit says it breaks easily. Okay, that is fine. I give only a small angle for bending there. Then it will not break. But what is the problem there? You noticed. Yes, you can see that it has a poor surface finish, isn't it? The poor surface finish will be there. Yeah, it is not smooth over there. Yes, okay. And then we call that as orange peel effect. You can see that the surface is somewhat burrs are there on the surface. Okay, that is what we call the orange peel effect. So orange peel effect will be higher if the grain size is a coarse one. That is the case. Next, the fifth one is the spring back. Okay. So what generates a spring back? See, that is when this sheet metal is subjected to bending, or like that means it will bend to a particular dimension, but it quickly regain its original shape. Try to regain its original shape. Because of that, certain dimensional variations will be there. That is because of what? Because of elastic recovery. So this material is bent like this, and when I release this force, you can see that it will slightly rises up. That is trying to regain the original shape. So I will not get the proper dimensions. Dimensional accuracy will be less because of this what? Because of this spring back. That is because of the elastic recovery. So that can be overcome by means of certain processes. Okay, like reduce this spring back by means of the two main processes like overbending and by means of the process called as bottoming. Okay, what is overbending? So if we increase the bend angle, okay, bend angle, instead of 90 degree I am going to give it as a 85, that is it is decreasing. Okay, if I decrease that bend angle, what will happen? When it is released, yes, it will come back to its original dimension. Okay, and another one is the bend radius. Bend radius will also be reduced. Next is bottoming. In this case of bottoming, we are applying the force again and again on that particular area to get it overbent. So these are the things to be performed to reduce the spring back. Is it clear to all? Next, we are going to discuss about the new topic, that is the shearing, blanking and punching. Shearing, blanking and punching. Okay. And punching. I told you that the sheet metals can perform the cutting operation. In the first year, you learned the sheet metal, you already experienced the sheet metal in your engineering workshop, and at that time, by using what you perform the cutting operation of that sheet. Is it by means of hacksaw? Is it by means of hacksaw? Are you sure? Yes, it is by means of a cutter, right? It is by means of a cutter there. Yeah, that means it is just like a scissor, right? How that scissor cut a piece of paper, but what force is there inside that when you undergo the cutting operation by using a scissor? What kind of force is applied there? What kind of force is applied there when you use a scissor there? Yes, it is applying a shear force there, isn't it? Yes, it is applying a shear force there. Yes, okay. Clear to all. So the sheet metals can be cut by means of applying the shear force. That is one important thing you have to keep it in mind. So to undergo this shearing or undergo this cutting operation, the one important factor which governs is the clearance. Clearance between what? The clearance between the punch and die. The clearance between the punch and die. Okay. It is based on that clearance, the blanking and the punching arises. Okay. What is the next factor which governs the shearing process? The next factor which governs the shearing process is the punch speed. How fast that punch hits the workpiece and it is drawn towards the die. Okay, how fast? Okay, if the punch speed is less, means what will happen? Yeah, it will produce some rough surfaces. Okay, next is, what about the roughness there? The roughness will be more if the clearance will be higher. The roughness will be more if the clearance will be higher. That is the case. Okay. So you might have noticed the paper cutting machine in your photostat stops. Yes, you can see that there exists a punch as well as a die is here. Okay, that lever is the punch and the paper is kept in between the punch and a die there like this. And then this is the punch and this is the die. Okay, now I am going to move this punch towards that direction, opposite to the die, and I am giving the cutting force. The cutting operation will take place, but the surface will be somewhat blurred, isn't it? That is, you will not get the proper surface finish there, isn't it? That is why because of the more clearance between the punch and die, it will produce an irregular surfaces on the paper sheet, isn't it? Paper. So if I am moving towards the left side, if I am moving towards the left side, yeah, what happens? The gap will be lesser, and the surface finish obtained will be more. You will get the proper surface finish. So roughness depends upon the clearance. The roughness increases if the clearance between punch and die is more. Clear to all? Yes, okay, fine. Next is the force required to cut a paper. See, I know the shear strength of the paper. Okay, ultimate shear strength is known to that. So if I am applying that much force, I can't undergo the cutting operation. I know the shear strength. Okay, why I am giving more force than that of that? Yeah, Google is saying that it is because of irregularity. Allowance is done by another version. Is it like that? Is it because of that? Why I give more force than its ultimate strength of the sheet, There exists the certain friction between the punch and die. Am I right? To overcome that, you have to give extra force over there. Got it? So, take in the case of a sheet, the stress is the sigma is the ultimate tensile strength of the material, and A is the area. If I know these two things, I can easily find out the force required to cut that material. Suppose L is the length of the sheet and T is the width of the sheet. Okay, T is the width of the sheet. Then I can find out the force required is sigma into T into L. Okay, then to overcome this friction force, an empirical relationship is generated. Okay, and that is equal to F max is equal to 0.7 sigma u T into L, where sigma u is ultimate tensile strength, T is the thickness of the sheet, and L is the length of the sheet. So this is the expression. Is it clear to all? So next is we are going to discuss about the shear zone geometry. So here is the die for undergoing the cutting operation or shearing operation, and here is the punch. In between that, the workpiece is kept. So when I apply the pressure by using the punch, yeah, you can see that the workpiece will appear like this as shown in the figure. You can see that there exist certain fillets or corners that is in contact with the punch. That is what we called as rollover zone. Okay, that is called as the rollover zone. And then this is the punch and this is the die. Let me enlarge that area. I am going to name this point as A, B and C and D. I am going to enlarge that much area. After cutting, after shearing operation, how it appears? It will be like this. Please check this figure. Okay, it will have a shape like this. Say these two sides are somewhat finished. Say here it is A, B, C and D. This is the points, and you can see that these surfaces are polished. And you can see that there exists a small depression at this portion. Small depression is there at this portion. that depression is what we called as dishing. That is what we call as dishing. Okay. Next is, you can see that certain peaks are there here at the ends, that is at the point A and B. That is because of the plastic deformation. You know the ductile materials are using here, isn't it? So what will happen is, during the shearing process, the buds are formed. That is formed due to what? That is formed due to the plastic deformation. And you can see that at the bottom, the lower side of that burr is somewhat rough. We call that as a rough area. And the initial points, that is just below the D and C, that points, these points, okay, these surfaces are burnished area. That is, it is in contact with the punch and the die. Due to the friction between the punch and die, it get polished off. That is what we call as the burnished area. Okay. Why this burr is formed there? Due to this ductile material, what will happen is, due to that plastic deformation or plasticity, it get adhered on the surface of the punch. Okay, that is why that side will get peak up. That is called as the roughness. Due to the rise in temperature during this forming, what will happen is, some of the material will adhere on the surface of the die. Okay, that will lead to the rough area. Okay, that is it because of that adherence. Because of the adherence, it is formed over there. Hope it is clear to all. Yes, fine. Okay. Next we are going to discuss is the blanking and the punching. Okay, you have heard this name in the second module, right? The blanking and punching. Yes. So in the case of a blanking, we are cut a blank of having different shape from a sheet. That is the material which is cut out from that sheet is what we call as the blank, which is used for. In the case of punching, we can see that small holes are put on the sheet there. That is called as the punching. So that is the difference between the blanking and the punching. Okay. So what is another difference? That is in the case of die and punch. The clearance in the blanking between the die and the punch differentiate the blanking and punching. Okay. The clearance between the die and punch differentiate the blanking and the punching. So in the case of blanking operation, I give you a code there, BP. Say you can remember that as blood pressure. Okay. So that means here in the case of blanking, the clearance is provided on the punch. In the case of blanking, the clearance is provided on the punch. That is the case. Okay. And in the case of a punching, what is the case? In the case of punching, the clearance will be provided on no, it is not provided on die. We can't change the clearance of a die. Blank. That is a workpiece there. So it is in the punch and die. It is in the case of blanking, it is provided on the punch. The clearance is provided on the die. Clear? Okay. I am going to undergo the blanking operation. So the blank to be produced should have a diameter. Okay, should have a diameter, take it as dB. Okay, is taken as dB. Then the C is the clearance, which is provided where? The clearance should be provided where? Arrowman says that it is on the punch. What about his opinion? Is it die? Please check here. You can see that in the case of blanking, where we have to give the clearance, I give the code BP. It is provided on the blanking is provided on the punch. Okay, the clearance is provided on the punch. Use that code BP. For blanking, it is punch. Okay. So C is the clearance provided on the punch. Okay. So let's make a drawing for that. Here is a die, and workpiece is kept over here, and then punch is here like this. And the workpiece is kept in between these two. The punch is moving downward. So in this case of blanking, the punch we have to provide the clearance. So I am going to give the clearance on both sides. So here one C, on the left side one C, and the right side also one C is there. So how many C's? 2 C's are there, right? So what shall be the diameter of punch? Diameter of the punch is how much? Please say, what shall be the diameter of the punch? dB minus 2C. Am I right? Yes. Then what about the diameter of the die then? The diameter of the die will be equal to the dB itself. Isn't it? The diameter of the die is equal to the dB itself. Okay. Yes. Same way, let's consider the punching operation also. Let me draw the figure. Here the punch is here, and the workpiece is kept in between that. In this case of punching, we have to give the force where? In the case of punching, clearance where? In the die, isn't it? Yeah, C is the clearance provided in the die, and the hole to be produced is taken as a DH. Okay, so here one C is provided, and here also one C is provided. Okay, the hole to be produced is taken as DH. Okay, then what shall be the diameter of the die? What shall be? Yes, DH plus 2C, right? DH plus 2C will be the diameter of the die. Then what shall be the diameter of punch there? Yes, it is equal to DH. So that is the main difference between a punching and a blanking. Hope it is clear to all, right? Yes. Next we have to discuss is the bending operation. Bending. Okay. So a material, sheet metal is taken like this, used to be bent at a particular angle, and after bending it will be like this. Okay. And I'm going to draw the axis line also is drawn, and we call that line as neutral axis. Okay. And this is the outer surface of the bent sheet, and this is the neutral axis. The region above the neutral axis is subjected to what kind of force? The region above the neutral axis is subjected to what kind of force? It is subjected to tensile force, right? It is subjected to tension. Why? Because the change in length is higher there. That is, increase in length is there. You can see that AA dash is increased a lot, isn't it? And then what about the BB dash? That is there. That is having a compression there. That is, the reduction in length will be there. So here, this is the tension area. This is the compressive area. Okay. So that is happened in the case of a bending. Is it clear to all? And no option is taken place in the neutral axis there. Next is, what is bend radius? See, that is from the point to the inner part of the bend. We are not considering about the outer part. The inner part of the bend is what we call as the bend radius. We are not considering the outer part there. Clear to all? The bending will vary, depends upon the die used. Say in the case of this one, it is using a V type of die and punch is used there, and another type is by using a whipping die. Here one die is kept, and over that the workpiece is kept over here like this, and on that, to hold it firmly, the pressure pad is kept. The pressure pad is kept, and then that in contact with the pressure pad, the punch is also kept like this. Okay. And this is the wiping die. And here is the blank or sheet metal. Here is the pressure pad, which gives the compressive force, or which tights the workpiece on the wiping die. Here is the punch. When the punch moves downward, it will get bent off. Okay, so you can see that the pressure pad is moved to a little bit away from this die, isn't it? So that is used for providing the bending radius over there. Okay. So let's see what happened after bending. It will get bent off like this, and the punch will be here near through the surface of the workpiece like this, and the pressure pad is still on the top of the workpiece, holding it firmly on the surface of the wiping die. Okay. So this is what we call as edge bending. This is what we call as the edge bending. So is it clear to all? Yes, fine. Next is, how much is the bending force which is applied? The one, it depends upon the shape of the die which is used, and another one is the sheet material, the material of that is the workpiece, the nature of the workpiece. So the shape of the die is given by a factor called as K. So FB is equal to the expression, empirical expression is KL sigma U T square divided by D. Okay, where K is the parameter of that sheet of that material, and what is D over there? See, in the case of a V, the D is here like this. In the case of this one, in the case of the edge bending, in the case of edge bending, that D is this much gap is the D. Okay, clear? Okay, fine. Next topic we have to discuss is the press brake forming. Yeah, it is an old method of a forming process. Yes, in the case of press brake forming, it is using a U and V shaped dies are used there. It is used for corrugating the sheets, isn't it? The sheet metals can be used there. The punch is moving downward, the sheet metal will get a turn off. And next is we discussed about the tube bending there. Okay, there exists different type of tube bendings or process are there. That is based on what? Based on what? It will vary based on what? Based on the angle, then based on the bend radius, isn't it? And based on the diameter of the tube, it is going to vary, isn't it? Yeah, with thickness of the wall thickness, it will vary. Okay, based on those things, the tube bending, the various processes are generated. Yes. And then first one is the rotary draw bending. In that, the main items present are what? The movable arm is there, clamp is there, and the pressure pad is there, isn't it? So in that case, the clamp held firmly the workpiece material on the movable die, isn't it? The clamp held firmly on the movable die. Okay, and the movable die will rotate in this direction. The clamp held firmly over it. Okay, and then by the pressure pad is there, which gives a downward force on that material. When it is rotated, yeah, it will acquire the shape. And next is in the case of compression bending, it is similar, same as the previous one. The difference is that here the foam die, that is fixed die, is used there, and the wiper is used to change the shape, isn't it? The clamp held firmly on the surface of the foam die. Okay. And the next one is the mandrel bending. In the case of a mandrel bending, we can see that a mandrel is kept inside this one. So the diameter can be, the diameter at the end of that bend will be the diameter will remain constant there, isn't it? That is, we will get the perfect diameter itself. Okay. So in the previous two cases, the dimension will vary. And the last one is the stretch bending. That is, by using the gripper, we are giving a tensile force, and then the perpendicular force is given by means of a V die over there. Okay. And it will get bent off. So these are the different types of a tube. Next is deep drawing. In the case of deep drawing, it is used for making cups. So what are the main process it has to include? The bending, the straightening, isn't it? The bending, straightening, etc. can be used. It is used for making the tank and the sink. The deep drawn process can be made by means of deep drawing. Okay, what are the main steps included here? Yeah, the first one is the bending, then straightening, isn't it? And then again the compression force is given there. Yes, right? And then again the bending and straightening process is carried out, right? Okay. Next is the rubber forming process. The first one is a Gurin process. In that, it uses a rubber pad inside the ram there, isn't it? rubber pad is used inside the ram there. That is what we call as a Gurin process. And because of that high force, it will deform, and because of the presence of the rubber, the uniform force is applied on the sheet to acquire the shape of that formed die. That you can see on the next figure. Okay, here you can see. And next is the hydroforming. In the case of hydroforming, the uniform pressure is applied by means of the fluid present inside this ram. The ram end is supported by means of the rubber diaphragm. Instead of a rubber pad, only rubber diaphragm is placed there. Another specialty is that the punch is moving upward from the bottom side, isn't it? Okay. And it will acquire the shape of the punch, and uniform force is applied by means of that hydrostatic force. So this is the case. Fluid pressure is there. And the next one is a spinning. The conventional spin, three types of spinning processes are there: conventional spinning, shear spinning, and tube spinning. In the case of conventional spinning, we are using a die which is kept inside the lathe. And then the main difference between conventional and shear is what? In the case of conventional, the T, that thickness will remain constant. What about the case of shear spinning? The T will vary. That is the difference. The T will remain constant in the case of conventional. The T will get reduced in the case of shear spinning. That is the difference. In the case of tube spinning, it uses a mandrel there. It is used for reducing the diameter of that tube by using a roller. So these are the things. Now let's go through the note. Here you can see that all these things we discussed in the class is present over there. Elongation, anisotropy, grain size, spring back, all these things are there. And then the shearing and the bending. The shearing bending. In that the shearing, the clearance is a main factor that is noted here. And then the punch speed. The shear zone width depends upon the punch speed. The next is roughness depends upon the clearance. The force produced due to the friction between the blank and the die. Okay. And then here shows the shear zone geometry. The bar area you can see. The finish zone, the rough zone you can see. And the next is the explanation of that shear zone is explained here. Please go through that. Next is the blanking and punching. The main difference is noted there. Here it shows the dh plus 2c and db plus db minus 2c is shown there. Okay. Die hole diameter is dh plus 2c. In the case of a punch, in the case of blanking, the clearance is provided for what? In the case of blanking, the clearance is provided for what? Punch, isn't it? BP. Use the code P. BP. Okay. Next is the figure for the blanking and punching is shown here. Next is the bending. The V bending is shown here, and the edge bending. The figure is shown at the bottom here. You can see, and the terminology of that bending is shown here. You can see that the compression side as well as tensile side, the bend radius, neutral axis, those things you can see. And next is the spring back. How it can be overcome by means of overbending and bottoming that we discussed. Next is the press brake forming. You can see that the V-shaped dies and V or U-shaped dies and punch are used there for corrugating the sheet, that you can see. Then the tube bending. Yes, you can see the different type of tube bending processes. That is a rotary die. Here you can see that the movable die is seen, which rotate to form the shape. And next is here you can see the neck compression, where it is using the wipers by means of repeated motion. Next is a mandrel. Yes, the diameter of that hole will remain constant since it is using the mandrel inside that. And next is the stretch bending. And next is the deep drawing. You can see that initially the bending operation takes place. Next is a straightening operation, and last the compression is taken place at the flange area. At last the deep drawing is attained. Okay. And next is the rubber forming. The first one is a Gurin process. It uses a rubber pad inside this one, and the force is applied over here. Then next is here, in this case only a diaphragm is there. The punch is moving from bottom and the shape is attained. See, now it gets touches the surface of the workpiece, and it moves. When it moves upward, it will acquire the shape of the punch that you have seen in the figure at the bottom side. You can see here. This is a finished product. Okay. Next is spinning. That note is not ready. That I will made and upload it. Okay. So hope it is clear to all, right? Hope this is clear to all, right? Yes. I think we can stop for today. Okay then. Bye all.